Okay. Okay. Are you able to see my screen, dear students? Please respond. Hello.
Yes, sir.
Yes. Okay. We'll continue to the next class. Okay. Lastly, good morning, dear students. Welcome to the DOM class, Unit 3, Balancing of Forces. Already we have discussed the four cases in the balancing of the forces. Let me explain briefly the previous one. First, we have discussed the balancing of single rotating mass in a single plane. Second case is balancing of single mass by two masses rotating in two different planes. This can be done by two methods. That is, disturbing mass is in between the two balancing masses, case 1, and case 2 is the disturbing mass on either left side or right side. Suppose if the disturbing mass is on the left side, these two balancing mass on the other side. And case 3 is balancing of several masses rotating in the same plane. Now what we are seeing here. So this we can solve by two methods. One is by analytical method and second one is the graphical method. And last class we have discussed about the analytical method, how to solve this one. If you see with respect to the x-axis, you are having four masses m1, m2, m3 and m4. These four masses are being located by an angle theta 1, theta 2, theta 3 and theta 4. Okay, these four are the disturbance masses. Due to these forces, centrifugal force Fc1, Fc2, Fc3 and Fc4 is being erased. Now our aim is to balance all these forces with a single mass. So this is your balancing mass M. This balancing mass is being located by an angle theta with respect to this x-axis. And Fc is the centrifugal force generated due to this balancing mass. In analytical method, we have solved resolving the force along x-axis and resolving the forces along y-axis. You can see here. If we resolve the force along x-axis, m1r1 cos theta 1 plus m2r2 cos theta 2 plus so on up to 4 masses. Similarly, with respect to vertical side, m1 r1 sin theta 1 plus m2 r2 sin theta 2 plus so on. Now the resultant centrifugal force is your Fc, which is given as root over sum of all the horizontal forces square plus sum of all the vertical forces. So this Fc gives your balancing mass. Okay, so we will see here. Already we have discussed here. This Fc is nothing but your product of balancing mass into radius. Okay, this is the product we are going to get here. Similarly, at what angle we need to keep this balancing mass? This is given by tan theta, which is equals to sigma v by sigma h, or theta equals to, from this how we can write, tan inverse sigma v by sigma h. Okay, this is how we can keep the position of the balancing mass. You can see here. This is the theta. How we can find with help of the tan theta and
Sir,
resultant
screen
force.
is not appearing.
Yes, screen is not appearing.
Yes, sir.
No, I'm sharing screen. No, right? It is maybe your
Sir,
net-
it's appearing for everyone, sir.
yes, your network may be slow. Okay, it is appearing. Okay, this is how we can find the resultant force Fc and angle theta. Okay, now let us see the, this is how we can find Fc is equals to, sir Madhu sir, go slow sir. Fc is equals to m into r. This is how we can find the balancing mass and radius. Now in this class we are going to discuss the graphical method. You can see the 6 steps, step by step they have written here how to find the graphical method. First, your aim is to draw the space diagram with the position of several masses. Sir Ganpat sir, please sir, చిన్నగా మాట్లాడు సార్. ఇప్పుడు హెరాస్ చేస్తారా దానికోసం? First of all, draw the space diagram with the position of several masses. This step 1. Second step is find out the centrifugal force exerted by each mass on the rotating shaft. Next, third step is now draw the vector diagram with the obtained centrifugal forces. Let me keep the laser point. Draw the vector diagram with the obtained centrifugal forces such that AB represents the 2 minutes students. I am changing my position. Okay, welcome back. Small correction. Okay, now let us see the balancing of several masses rotating in the same plane. Graphical method. 2 minutes. I want to set down the settings. Hmm. So now let us discuss step by step. First, draw the space diagram with the position of the several masses. Second step, find out the centrifugal force exerted by each mass on the rotating shaft. Third step, draw the vector diagram with the obtained centrifugal forces such that AB represents the centrifugal force exerted by the mass M1 in the magnitude and direction to the suitable scales, suitable scale. Similarly, draw BC, CD, DE. Now, as per the polygon law of forces, the closing side AE represents the resultant force in magnitude and direction. The balancing force is then equal to the resultant force, but in opposite direction. Now, let us find the magnitude of the balancing mass M at given radius of rotation are such that mr omega square is your resultant centrifugal force. From this, we can find out the M into R, which is the resultant of M1 R1, M2 R2, M3 R3, and M4 R4. Now, let us solve this one. How to do this one? Now, you can see here. If you see, different masses are available here. Okay, mass M1 at radius R1, mass M2 at radius R2, mass M3 at radius R3, mass M4 at radius R4. Okay. Oh, this is a different plane. Sorry. Hmm. Let me keep one slide here. New slide. Yeah, now you can see balancing of several masses rotating in the same plane by graphical method. Let me explain how to do this, how to solve this one. Already we have discussed the procedure how to solve this. Now with respect to this x-axis, m1 is the mass whose radius which is located at radius r1, making an angle theta 1. So this we call it as a configuration diagram. This total we call it as the configuration diagram. So let me show how to draw this configuration diagram here with the same. So I'm drawing the configuration diagram. Hmm. So let me use different color. So is this color green is visible to all of you, dear students? Please answer. Okay, let us. This is our x-axis. So with respect to this point, I am having mass m1, Similarly, this is mass M2, somewhere else here, mass M3, and this is the position of the mass M4. These four masses, M1 is located at radius R1, M2 is located at radius R2, M3 at radius R3, M4 at radius R4. This M1 is making an angle of theta 1 with respect to this x-axis. Similarly, this M2 is making an angle theta 2. Similarly, if I extend this horizontal line with respect to this line, M3 makes an angle of theta 3, and similarly M4 makes an angle of theta 4. Now my aim is to keep the balancing mass. Let me show balancing mass with a different color. I'm taking a red. So somewhere else I'm keeping. This is my balancing mass M, which is located at radius R. This makes an angle theta. Okay. So if I see here, I'm having disturbance mass M1 located at radius R1, making an angle of theta 1. Similarly, second disturbance mass is M2 located at radius R2, making an angle theta 2. Disturbance mass M3 at radius R3, making an angle theta 3. M4 is the fourth disturbance mass, making an radius of R4, making an angle theta 4. Due to this mass M1, I am getting the centrifugal force Fc1. Similarly, due to mass M2, I am getting centrifugal force Fc2. Due to mass M3, I am getting the centrifugal force Fc3. Similarly, due to mass M4, I am getting the centrifugal force Fc4. These four are the disturbance masses. These four disturbance masses are being balanced by balancing mass M at radius R, located by an angle theta with respect to the x-axis. Okay, make balancing mass the magnitude M at radius R at an angle theta. So now my aim is to find what is the M value, what is R value, and what is theta value. This I can solve by analytical method. Already have shown how to solve the analytical method. Resolving the forces horizontal side and resolving the forces vertically and getting the angle theta. Now let us discuss the same with help of the graphical method. Now let me go to the previous slide. Now you can see here. This is your mass M1 making an angle theta 1. Similarly, this is mass M2 making an angle theta 2. Hmm. And this is your mass M3 make at radius R3 making an angle theta 3. This is mass M4 at radius R4 making an angle theta 4. So now this is my balancing mass M at radius R with respect to this x-axis. It makes an angle theta. Now you can see the vector diagram here. You can see the vector diagram here. How FC1 has drawn here. First, AB is your vector shows the FC1. First step is you are having the force vectors AB, BC, CD, and DE. This AB represents the force vector of the centrifugal force 1. This BC represents the force vector of the centrifugal force FC2. This CD represents the force vector of centrifugal force FC3. And this DE represents the force vector of the centrifugal force Fc4. So in a law, Polygon law of forces, the closing side of the polygon gives your resultant. In Polygon law of forces, always the closing side gives the resultant. Now we will see how these vectors have been drawn, how AB has drawn, how BC has drawn, how CD has drawn, and how DE has drawn. So first, how we can solve this one? If you see with respect to this x-axis, I'm using the pen again. Let me use. Okay. With respect to this x-axis, now you can see here a force vector Fc1. So how to calculate this Fc1? First, your aim is to calculate the magnitude of all the forces. Calculate Fc1, calculate Fc2, calculate Fc3, and calculate Fc4. How you can find the Fc1? We know the mass m1, and you know the at what radius it is being located r1, and at what angle it is making theta 1 we know. or we can write mr omega square. We know the angular velocity. We know m1 r1 into omega square. Similarly, fc2 is m2 into r2 into omega square. fc3 m3 r3 omega square, and fc4 is m4 r4 omega square. In all the forces, omega is constant. I am omitting, and I can write the centrifugal force as fc1 as m1 r1, fc2 as m2 r2, m3 r3, and m4 r4. Now, if I know the mass and radius, I will get some value. Similarly, for m2 alpha, I will get some numerical value. Similarly, for all this well, I will get some numerical value. In terms of, suppose m1 r1 is say a value a, m2 r2 is value b, m3 r3 is value c, m4 r4 is value d. So a, what are the units? Mass in kgs, radius in meter. This is also kg meter. C in terms of kg meter, D in terms of the kg meter. Now I know the magnitude of A, B, C, and D. A represents my vector AB, B represents my vector BC. Similarly, C represents my vector CD, and D represents my vector DE. Okay. Now you know up to how much length this AB has to be drawn. Similarly, up to how much length this BC has to be drawn. Up to how much length this CD has to be drawn. Up to how much length this DE has to be drawn. So the length of all these vectors, the length of the vectors AB is nothing but value A. Next, the length of the vector BC is nothing but value B. Now, the length of the vector CD is nothing but value C. And last one, the length of the vector D is nothing but value D. Okay. A is the product of M1 R1. B is the product of M2 R2. C is the product of M3 R3. And D is the product of M4 and R4. Okay. After finding all these products, we will get the some numerical values A, B, C, D. Suppose, assume this may be 10, 15, 20, 30. Randomly I am saying, I am not calculating. Randomly I am giving those values. Assume this A as 10, this B as 15, this C as 20, this D as 30 kg meter. So I can't draw a length of 30 kg meter. It means it's a huge length. So in that case, what we can do, take the scale. Okay. You can solve this by taking a suitable scale. How we can solve? So already we got vectors A value, B value, C value, D. A I am taking it as 10, B I am taking it as 15, C as 20, D as 30 kg meter. So the A represents my centrifugal force Fc1, which is nothing but M1 R1, which is given by the vector AB. B represents my, just random I'm taking this value, okay, kg meter, which is equals to Fc2, product of M2 R2, which is represented by the vector B and C. This C is my 20 kg meter, which is given by the vector Fc3, which is equals to M3R3, which is represented by the vector CD. And last one is my 30 kg meter, which is equals to Fc4. So that is the product of M4 and R4, which is given by the vector D and E. Okay, A, B, B, C, C, D, and E. These are the four vectors. Now my aim is first to draw a line AB of length 10 kg meter. But in length, how I can draw the length in terms of meters only. Now I have to take the suitable scale. Taking suitable scale. How I can take, suppose this 10 is the multiple of 5s. Okay, I can draw it as 2.5 kg meter is equals to 1 centimeter. I'm taking a scale 2.5 kg meter equals 1 centimeter. You can take 2 also. Okay, you can take 2 also. Nothing is wrong. Just I'm taking a 2.5. Let us go with 2 only. 2 kg meter equals to 1 centimeter. Now what is A value will come? 10 kg meter is nothing but how much it will come in terms of length? Can anyone answer? The students, 10 by 2. That gives your length of AB is 5 centimeters. Similarly, come to BC. Now this is 15 kg meter. Now 2 kg meter is 1 centimeter. Now 15 kg meter, how much? 15 by 2. That comes as 7.5 centimeter. Similarly, with respect to 20 kg meter. 2 kg meter is 1 centimeter. Now 20 kg meter is how much? 20 by 2. That comes as length of 10 centimeter. And last one is D, 30 kg meter. Okay, 30 kg meter, 2 kg meter is 1 centimeter. Now 30 kg meter equals how much? 30 by 2, which comes as 15 centimeter. Now what I have done? I have converted the centrifugal force Fc1 in terms of the vectors AB, whose length is equal to 5 centimeter. I am drawing in terms of vectors whose length is 5 centimeter, but this is equal to 10 kg meter. Force this force is 10 kg meter, but in terms of length it is 5 centimeters. How I got this one? With help of the suitable scale. Now we will see how to draw this one. Now we know the angle made by this vector AB or Fc1. Now let us see. Now this Fc1 makes an angle of theta 1, Fc2 centrifugal force 2 making an angle of theta 2, Fc3 is the third centrifugal force making an angle theta 3, and Fc4 is the fourth centrifugal force making an angle of theta 4. Okay, let me go to the previous slide now. Now you can see here, with respect to this point, what is the angle made by the centrifugal force theta 1? You can see this AB and this line, both are parallel to each other. If you see here, you see this line Fc1, which makes an angle of theta 1 with the same length with respect to this point. You can see here, this is my starting point. With respect to this point, I'm drawing a line Fc1 making an angle of theta 1. Now come to point B. This is my again axis point. What B is making an angle? Can anyone answer? What is the position of this B with respect to X? Dear students, hello, 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 anyone there? Hello, hello, hello.
Yes, sir.
Yeah, why you are not responding? No one is responding. Okay, now tell me. Okay, let me start my slideshow. Hmm. Now tell me, what is the centrifugal FC2 making an angle? What angle it is? With this diagram, with respect to X, what is the angle made by the centrifugal force FC2? Can anyone answer? Hello? Hello? So this is perpendicular, making an angle of 90 degrees. Exactly, we can see. Now if you see here, this is your vertical line, making an angle of 90 degrees. Now if I see this, this FC2 and the vector BC, both are parallel to each other. Okay, this is how I'm drawing the second vector. Now again, how much length I have drawn this second vector BC? Okay, let me come from the first point. AB is my first vector. I'm drawing a line AB making an angle of theta 1. Up to how much length I have to draw? For example, I have taken here. AB, I need to drop to 5 centimeters. BC, I need to drop to 7.5 centimeter. CD, I need to drop to 10 centimeter. And DE, I need to draw up to 15 centimeter. Okay, let me draw here itself. Okay, just I'm taking a reference point. With help of this reference point, first vector I am drawing FC1. This is my FC1. This is A and B, whose length is 5 centimeters. This is drawn by an angle of theta 1. But this value, the vector AB, moving in this direction, the length of AB is 5 centimeters. Okay. Now come to point B. Just locate again the second reference point. Now you can see in the diagram. This is your configuration diagram. What is the position of this MC2, which is making an angle of 90 perpendicular exactly? Okay. So with respect to B, this is exactly perpendicular. Okay, that is what I am drawing here again. You can see here with respect to B, how much length I need to draw? 7.5 centimeters from B, point B, up to a length of 7.5 centimeters. Now this is exactly perpendicular, 90 degrees. This vector making an angle of 90 degrees. Okay, again, third vector CD. You have to draw up to 10 centimeter length, making an angle of theta 3. Now we will see what is the angle made by the third vector. You can see here, third vector, how this is drawn. It is going like this. The same line I am replacing here. If you see the configuration diagram and force vector diagram, you can see this FC1 or the centrifugal force FC1 is parallel to this line AB. Next, this FC2 is parallel to this line BC, and this centrifugal force FC3 is parallel to the line DC. You can see here these two are parallel to each other. And now fourth vector FC4 is parallel to the line DE. Okay, here randomly I have taken theta 3. You can see the position, same line. This is what I am drawing here. Okay, let me show with different color densities. This shows my vector CD, which is similar to the FC3. And next one is fourth vector. You can see here how the fourth vector is moving. Fourth vector is moving downwards like this, making an angle of theta 4. This you can solve with help of the protractor only. Okay. Now let me take next vector DE. DE is length. How much length I need to draw? Up to 15 centimeters, making an angle of theta 4 with respect to the x-axis. So with respect to the x-axis line, this makes an angle of theta 1. With respect to the x-axis line, this is making an angle of theta 2. With respect to the x-axis line, this is making an angle of theta 3. With respect to the x-axis line, all this vertical line shows the x-axis points. Okay, all the red line. This is my x-axis reference line. This is my reference line x. This is my reference line. Similarly, this is my reference line. With respect to x, the force vector AB, which is nothing but FC1, making an angle of theta 1. Similarly, with respect to x, this is my second vector, whose force is FC2, making an angle of theta 2. Similarly, with respect to CD, this is my force vector FC3, making an angle of theta 3. And last one is the with respect to x, DG is my force vector FC4, making an angle of theta 4. And now the closing side of the polygon gives my balancing mass. Just what I'm doing, I'm joining the line A and E. Next step you have to do is join the line. After drawing AB, BC, CD, and D, next you have to do the join the line E and A. Now what you have to do is measure. Let me use one more color. Measure the vector AE. You will get some x centimeters in length. Got it? Measure the vector AE. You will get in terms of some x centimeter into length. Already we have taken the scale. 1 centimeter is 2 kg meter. So already this FC1 I have drawn with the length of 5 centimeters. This BC I have drawn with the length of 7.5 centimeter, and CD I have drawn with the length of 10 centimeter, and this DE I have drawn with the length of 15 centimeter. Similarly, this also gives my some length here. Instead of x, let me take randomly. For example, I'm getting this as 10 centimeters. Assume. Okay, I have not drawn with the scale. Just I'm assuming this x centimeter. This which is equal to 10 centimeters. Okay. Now convert the centimeters into force vector. This AE gives my what it is going to give a balancing force Fc, which is given by the m into r, which is nothing but vector AE, whose length is x centimeters. This x I am assuming it as 10 centimeters. Now this 10 centimeter I am converting in terms of the kg meter. 1 centimeter is 2 kg meter. Now 10 centimeters will come how much kg meter? Please answer. 10 into 2, that is 20 kg meter. You can see here 1 centimeter is equals to 2 kg meter. I have taken the scale. Now 10 centimeter comes as the 10 into 2, 20 kg meter. I am getting in terms of the mass into r. The product of mr I am getting in terms of 20 kg meter. How I can write the 20? I can write 4 into 5 or 5 into 4 or 2 into 10 or 10 into 2. Let me explain here. Now what is the angle made by this? If you see here, again now this is your x-axis line. This is the angle theta. Measure this angle. Okay. Next step is measure this angle. This gives the at what position this vector has to be placed. Okay. Measure the vector AE and measure the angle made by the vector. Measure vector AX centimeters. Next ఏం చేస్తారు? Measure angle made by vector AE. This two you have to do. Measure the vector AE, will get in terms of x centimeters. Next, measure the angle made by the E, which is equals to theta. This is the graphical method. Okay. Now let me see. Now I'm getting FC is equals to M into R. How much I'm getting? 20 kg meter. Now you can see how to write this M into R. I can write 2 into 10 or 5 into 4. Two possibilities are there. I can may use 2 kg mass and 10 meter radius, or vice versa also I can do. This is M into R, I can choose. M is 2 kg, radius is 10 centimeter, or I can choose mass as 2 kg and radius as 2 meters. This is case 1. Second case, how I can do 5 kg mass at radius of 4 meter, or 4 kg mass at radius of 5 meters. Okay, like this you can get the product of the mass into R and angle theta. So next what you have to do is take a scale, and I will give you one problem related to this. Using protractor you can solve. Or I would like to go for the next case. Are you clear with this, dear students? Now I will end up with the graphical method. Is it clear? Hello? Hello? Please respond. Hello? Yes.
Yes, sir.
Is it clear? Graphical method?
Sir.
Okay, I will ask randomly some students. Roll number 6070. Tamimuddin. Yes. Roll number 6070. Tamimuddin. Are you there? Hello? This fellows. 6085. Tirupati Rao. 6016. I'm taking that, and if you don't
Yes,
respond, I
sir.
will
Yes,
yeah.
sir. Present.
Yeah, tell me how to find out the angle made by this balancing mass. Are you following now? Just on the mobile and you are leaving somewhere else.
No, sir. I'm following, sir.
Okay. Roll number 2. Please respond. Roll number 2. If you don't respond, I will don't keep these videos in YouTube. Okay. Don't think I am going to post in YouTube. I will never post in YouTube. I will remove all the videos also. Roll number 56. Roll number 62. Okay. Roll number
Yes, sir.
74. Please respond whenever I'm asking. Okay.
Myself 6062, sir.
Okay. I will stop here my presentation. So if you are having any doubts,